Howdy, folks. Let's talk about solving some multi-step equations. Yeah! Okay, so to solve multi-step equations, you're gonna use the same properties that we've been using. The properties of equality, the inverse operations, properties of real numbers, and your goal is always to isolate the variable. Get that letter by itself. Okay, so how is this equation different from equations you've seen before? Well, the variable shows up in two places, two different terms, and we can simplify that by combining like terms. So 5m and 2m, what did I do there? What did we do? We switched the position of the 2m, and think of this as plus negative 23, plus negative 23. We just switched the, what did we use there? We used the commutative property of addition. Now what do you think we're going to do? What do you think we're going to do with these guys? Why did we put them next to each other like that? Because we're going to combine those like terms. Now golly, what are we going to do next? Remember, we're always focused on our letter. We're always staring at that variable going, what are they doing to my variable? And how can I undo that? Well, they got minus 23 and times 7. So reverse order of operations says we try to undo the addition and subtraction first. So I would like to add 23 to both sides. Or you can write it like that. So negative 23 plus 23 is 0. So we get 7m by itself over here, and 28 over there when we simplify. But my m is still not by itself. What's happening to my m? It's being multiplied by 7. And what is the inverse operation of multiplying by 7? You said it. Divide by 7. So when we simplify, 7 over 7 is 1. So we got 1m. 28 divided by 7 is 4. Well, let's see. How do you know if that's right? You can always check. So 5, plug it into the original equation. 5 equals 5m minus 23 plus 2m. So let's substitute a 4 in for each m. So that's going to be, let's see, 5 times 4 is 20. 2 times 4 is 8. So 20 minus 23 is negative 3, and negative 3 plus 8 is 5. So, bada boom, bada bing, we got the right answer. Congratulations to us. Okay, so see if you got it. Pause it. Try to work these out. See if you got it. Push play when you're ready to see if you got it. Okay, so this is really 11m plus negative 8 plus negative 6m equals 22. And so I can use the commutative property to switch these two. So that what I really have here is 11m minus 6m minus 8 equals 22. And I can combine these like terms. 11 minus 6, you said it, it's 5. So 5m minus 8 is 22. Here's my variable. What's happening to it? It's multiplied by 5. 8's being subtracted. And I need to get rid of addition and subtraction first. So I'm going to add 8 to both sides, because that is the opposite of subtracting 8. Negative 8 plus 8 is 0. So I just got 5m over here. 22 plus 8 is 30. And then to get m by itself, all I need to do is divide both sides by 5. And I get m equals 6. And then you can plug that in to find out if that's super true. 11 times 6 minus 8 minus 6 times 6 equals 22? Question mark. 66 minus 8 minus 36 equals 22? Well, let's see. 66 minus 36 is 30. So then that makes 30 minus 8, which is 22. Holla! Okay, so now do I have to go through all the mumbo jumbo here every time? If I'm doing a formal write-up, I'm going to write the mumbo jumbo and I'm going to write the reasons why over here. But if I'm just working on a problem, I can say my like terms are 5y and negative 2y, and I can combine them. 5y minus 2y is 3y. Plus 5 equals 14. I got times 3 and plus 5 doing stuff to my variable. Which one do I get rid of first? I get rid of addition and subtraction first. What's the inverse operation of adding 5? It is subtracting 5. So I'm going to subtract 5 from both sides of the equal sign using the subtraction property of equality. Then I get 3y equals 14 minus 5 is 9. Then I'm going to use the division property of equality. I'm going to divide both sides of the equation by the same number, which happens to give me a coefficient of 1 over here. And then 9 divided by 3 is 3. And I can check my answer too. Negative 2 times 3 plus 5 plus 5 times 3 equals 14. So negative 2 times 3 is negative 6 plus 5 plus 15 equals 14. 5 plus 15 is 20. So negative 6 plus 20 equals 14. Well, that's 20 minus 6, which is 14. So that checks out. Awesome. Ooh, multi-step equation with words. So Martha takes her niece and nephew to a concert. What a nice aunt. She buys t-shirts and bumper stickers for them. A very nice aunt. The bumper stickers cost $1 each. So bumper stickers are $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts and no bumper stickers. Martha's total is $67. What is the cost of 1 shirt? Well, how do we get that equation? Let's talk about that. Well, let's see what we got. The niece wants 1 shirt and 4 bumper stickers. Okay? So we know that the bumper stickers are $1 each. So this is $4 right there. So we got 1 shirt. That's 1s. We're going to say let s equal the price of a shirt. So 1s plus $4 plus 2 shirts, so 2 times s equals $67. So s plus 4, that's the niece's stuff, plus 2 shirts equals $67. 1 shirt plus 4 $1 bumper stickers plus 2 shirts equals $67. Now we can start solving this dude. So s plus 2s, we just used the commutative property there. S plus 2s is 3s. And that's just combining like terms. Then we're going to subtract 4 from both sides of the equation. We can write it like this or like that. We get 3s equals 63. Then we're going to divide both sides by 3. And we get s equals 21. So each shirt cost $21. Cool. So why don't you pause the video and see if you got it? And push play when you're ready to find out. Alright. So Noah and Kate are shopping for new guitar strings in a music store. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The book costs $16. Their total cost is $72. How much is 1 pack of strings? So what did we buy? We bought 2 packs of strings from Noah. So 2p, let's let p equal the number of the price of packs of strings. Kate gets 2 packs of strings, so we're going to add 2 more packs of strings, plus a book. And the book was $16, so that's plus $16. The total cost is $72. So we can simplify a little bit here. We can combine like terms. 2p plus 2p is 4p. Then we can subtract 16 from both sides. We get 4p equals 72 minus 16, 56. Then, to get p by itself, divide both sides by 4, and we get p equals 56 divided by 4, 14. So 1 pack of strings was $14. Once we get nice strings, I'll buy like the $6 ones. Alright, solving an equation using the distributive property. What is the solution of negative 8 times the quantity 2x minus 1 equals 36? Well, let's use the distributive property, like it says to, right? Negative 8 times 2x is negative 16x. Negative 8 times negative 1 is positive 8. And then we're going to subtract 8 from both sides. Then we're going to divide both sides by negative 16. And then we reduce this fraction. We know that 28 is 7 times 4, and negative 16 is negative 4 times 4. So the 4's will cancel. And a positive divided by negative is a negative. So we get negative 7/4. Alright, see if you got it. Go ahead and pause and see if you got it. Alright, let's see. 18 equals 3 times the quantity 2x minus 6. Let's use the distributive property. 18 equals 3 times 2x is 6x. 3 times negative 6 is negative 18. Now, look at your x. What's happening around our x? We've got a times 6 and we got a minus 18. We're going to get rid of we always get rid of addition and subtraction first. So what's the opposite of subtracting 18? Adding 18 to both sides. So we get 6x equals 18 plus 18 is 36. Then the only thing that's left being done to x is multiply by 6. The inverse operation of multiplication is division, so we're going to divide both sides by 6. So we get 36 divided by 6 is 6. So x equals 6. So let's check our answer. Let's plug it into the original equation. Does 18 equal 3 times 2 times 6 minus 6? Three times, let's see, 2 times 6 is 12 minus 6. 12 minus 6 is 6. And 18 equals 3 times 6, so that checks out. How about B? Can you solve the equation in part A by using the division property of equality instead of the distributive property? Well, let's see. 18 equals 3 times 2x minus 6. How could we use the division property instead? Well, here, okay, so here let's look at our x. We got it subtracted 6, multiplied by 2, and then this whole big mama is multiplied by 3. So instead of the distributive property, instead of bringing the 3 inside, what if we were just to divide both sides of the equal sign by 3? 3 divided by 3 is 1, and 1 times 2x minus 6 is 2x minus 6. 18 divided by 3 is 6. Then we would add 6 to both sides. And we would get 12 equals 2x. And then when we divide both sides by 2, we would get x equals 6. So the answer is heck yes. You can do it. Okay, so what is the solution of stuff with fractions? Alright, we gotta get common denominators if we're gonna do some subtraction here. So first thing we're gonna do is rewrite the fractions so that we have fraction coefficients of x. So 3/4 times x is the same as 3x over 4. Because if you think about multiplying the fraction 3/4 times x, well, x is x over 1, and you would get 3x over 4 times 1 is 4. So basically, 3/4 x is the same as 3x over 4. And then same thing with this. This is 1/3 times x. Okay, so now what? Now what? Now what? We need to get common denominators. The common denominator is 12 because 4 and 3 both go into 12. So how would we get a 12 on the bottom here? We would need to multiply the bottom by 3, which means we have to multiply this fraction by 3 over 3. What's 3 over 3? It's really 1. So I'm not changing the value. I'm multiplying by 1. I'm just getting a different version of it, but it's the same value. 3 times 3 is 9. 3 times 3 is 4. What am I multiplying by here? 3 times 4 is 12, so I'm multiplying this fraction by 4 over 4, which is 1. So that's why I get 4 over 12. Now that I have common denominators, I can combine like terms. 9/12 minus 4/12. 9 minus 4 is 5, so that's 5/12. And now I can multiply each side by 12 over 5, which is the reciprocal of 5 over 12. So this will cancel out because when you multiply reciprocals, you get 1 as the product. So we'll have x equals, and then 10 times 12 is 120 divided by 5, or you can think about it as like this. 10 times 12 over 5. But I know that 10 is 5 times 2, so 5 times 2 times 12 over 5, and then 5 divided by 5 is 1, so all that's left is 2 times 12, which is 24. So we get x equals 24. Okay, so now here's another method. That was one method. Method 1 was common denominator. Find a common denominator and then solve that bad boy. Method 2 is clear the fractions. And what you can do is, instead of giving everybody the common denominator, you can just multiply both sides of the equation by the common denominator. Why does that work? Well, because when you multiply, okay, so you're going to use the distributive property here. 12 times 3x over 4, that's 12 times 1 over 3x, 12 over 1, sorry, times 3x over 4. But that is 12 times 3x over 1 times 4. But I know that 12 happens to be 3 times 4. So 3 times 4 times 3x over 4. And 4 divided by 4 is 1. So 3 times 3x is 9x. So this is going to be 9x. And then when I multiply 12 times x minus 3, I'm not multiplying 12 times x minus 3. I'm multiplying 12 by negative x over 3. 12 over 1 times 1x over 3. 12 is 3 times 4. And then the 3's will cancel, and I got 4x. So minus 4x equals 120. So that's kind of cool, right? No more fractions. So this is kind of the work I did on the side over here, using the distributive property and multiplying. And then we get 9x minus 4x is 120. Combine these like terms over here, we get 5x equals 120. Divide both sides by 5, and you get x equals 24. So which way do you like better? Me, I'm a fan of method 2. Alright, why don't you pause and see if you got it. Okay, so I liked method 2. So what I'm going to do is I'm going to multiply both sides of the equation by the common denominator. Well, what's the smallest number that 5 and 4 both go into? I think it's 20. So I'm going to multiply both sides by 20. So I got 20 over 1 times 2b over 5 plus, distribute, 20 over 1 times 3b over 4 equals 3 times 20, 60. Okay, it's going to be helpful for me to think of 20 as 5 times 4. And again over here, 5 times 4 times 3b over 4 equals 60. Because 5 over 5 is 1. So then all that's left here is 4 times 2b, 8b. 4 over 4 is 1. So 5 times 3 is 15. So that's 15b. Now I can combine like terms. 8 plus 15 is 23b. And I'm going to divide both sides by 23. And b equals 60 over 23. Let's see. What could I multiply everything by over here? Let's see. 3 goes into 9, but 6 doesn't go into 9. But 3 times 6 is 18, and 9 goes into 18. So if I was to multiply everything by 18, I would get, this would be 18 over 9, which is 2. And then I got 18 times 5 over 6 minus 18m over 3. 18 is 3 times 6. 6's cancel. 18 is 3 times 6. Here the 3's will cancel, so I get 2 equals 3 times 5 is 15 minus, these 3's cancel out and we just have 6m. So look at my m. It's multiplied by a negative 6 and there's a positive 15 out front. If it's not easy for you to see that we should subtract 15 from both sides, it might help to rewrite this as addition. And then you can use the commutative property to flip these. And that way it might be a little bit easier to see that you really were adding 15. When 15 is positive, it's adding. So the inverse of adding 15 is subtracting 15. So from the right side of the equal sign and from the left side of the equal sign, negative 6m is negative 13. Divide both sides by negative 6, and m equals, negative divided by negative is positive, 13 over 6. And I don't reduce that because 13's prime and nothing's going to cancel out. Fake chicken is your secret phrase. Fake chicken. Okay, so what's the solution to this ugly thing with decimals? Yeah. So this equation contains tenths and hundredths here and here. The greatest number of digits to the right of any decimal place is 2. So you know that when you multiply by 10, it moves the decimal place to the right 1. So if you need to move it twice, you're going to multiply by 10 twice, which is 10 squared, aka 100. And that will clear out your decimals. So if we multiply everything by 100, it's going to move the decimal place over twice. So it'd make that 350, make that 2x, and it'd make that 24. Now, we got easy stuff. Subtract 350 from both sides, and then divide both sides by -2, and we get x equals 113. Okay, let's see if you got it. Pause it, and then push play when you're ready to see if you got it. Okay, so what do we have here? We have tenths. We've got 3 decimal places here, which is thousandths. And we've got hundredths here. Well, if I want to get this thing, if I want to clear the decimal on this one has the most, I'm going to have to multiply by 10 1, 2, 3 times. 10 times 10 times 10 is 1,000. So I'm going to multiply everything by 1,000. 0.5x minus 2.325 equals 1,000 times 3.95. So multiplying by 1,000 moves the decimal place 3 times. So I'm going to do my little thought bubble over here. 0.5 times 1,000 would be 1, 2, 3. There's my new decimal place. So that's going to be 500. So 500x minus 1, 2, 3. So 2,325 equals 1, 2, 3. So I'll get a 0 there. 3,950. I'm going to add 2325 to both sides of the equal sign. 500x equals 5, 7, 2, carry the 1, 6. Then I need to divide both sides by 500. And x equals 6,275 divided by 500 is 12.55. Bada boom, bada bing. Well, I think you should maybe think about practice 2.3. Definitely do the practice. If you're not doing these practices, you're really hurting yourself. And you shouldn't hurt yourself. Goodbye.